Yeah, thank you. Thank you very much, kind of staying back for the third day. I know like a lot of people move out after the second day. So we are here, like we are GridRaster. We are one of the companies who is kind of working on kind of bringing in AI and combining that with the spatial computing to do some of the stuff that otherwise are not possible. Today we're going to kind of share some of the work that we have done over the past few years and some of the outcomes that we are beginning to kind of see at various places, specifically on the manufacturing and sustainment kind of arena. So I'll just move ahead with the presentation. So a little bit about us. Fundamentally, we are kind of utilizing the cloud streaming technology and the spatial AI to be able to do some of the magic that we have been able to do. For example, kind of we are deploying this in operations and maintenance use cases, and we'll share some of them. In manufacturing assembly, how it's kind of helping to cut down the time and automate some of those processes, and also kind of in training and simulation, how we are using the capability to create fast digital twins to be able to create environments that can then be kind of streamed with high fidelity using the cloud streaming capabilities. And there are some interesting applications that I'm going to share where there is a convergence of AR and robotics that's kind of playing out, and we are able to take advantage of both the technology advancements that's happening and bringing in value in terms of automating some of the processes. Yeah, as we kind of work with a lot of our customers on the industrial side, specifically aerospace and defense, some of the key technical challenges that we kind of ran into was, one, the ability to kind of spatially understand the various assets, the ability to be able to create the 3D models of some of the assets that you may not have the CAD models, or the CAD models may not be meaningful anymore just because they go through a constant change and deformation and all of that. So it's a challenge that we ran into many environments, and that's something that we have been able to solve largely, and we're going to share some of the examples over there. The other challenge that we kept running into was the ability to able to precisely overlay and align the virtual assets on the physical assets. And it has been across the board, it has been a challenge, and there is many use cases which pretty much kind of depend on that accuracy. And using our capabilities, we have been able to kind of bring in a millimeter accuracy in terms of doing those overlays and alignments of being able to track different parts and the objects. So we're going to share some of that too with you. And then the last thing was to build out a full process simulation of any environment that you want to do. And that kind of plays out a lot to the capability around being able to support those high fidelity simulation by using our cloud architecture, and then being able to stream those high fidelity experiences onto any devices, like without worrying about what's the compute power on those devices. And this is kind of help us kind of bring in some of this performance and precision and the scalability, and do that in a very, very secure way, which is something which is kind of critical from a manufacturing and sustainment kind of an environment. I mean, these are some of the core IPs we're using, but I'll just kind of skip that, come to the 3D scanning and digital twin creation. I'll Rishi talk a little more about it. Yeah.
No, so as Dijam mentioned, right, like, so for what we are really trying to solve for is how do you enable spatial experiences in a very fast changing scenario. right? All the customers we work with, depots, warehouses, manufacturing places, the environment keeps changing all the time, and the problem of creating, in spatial, everything first starts with the 3D assets, but creating those assets is extremely expensive, takes longer, a lot of time. And just to give you an example, this video that you're seeing, Air Force, it takes them sometimes 3 hours to create a 3D asset of this F-15 wing. And the reasons are that you use the COTS devices to scan this, you have to go through a manual process to segment this, and then there are a lot of noise, clean those up, right? What we are doing here is really making it very cheap and easy to do, right? So we are collapsing the time, cost, all of those. So even in a very changing environment, you can create 3D assets in minutes. So what used to take 3 hours, we are able to do that in a minute. And the video, you can see that we just walk around using HoloLens. And we are building a multimodal system, right? So it's a software system. And we will go over this, that this one, HoloLens is the best choice. So we are giving those options to our customer. But everything is now automated. We go around it, scan it, segment the wing, and then remove all the noise, from there, and then the asset is now ready, right? So now our customers are moving into, Air Force wants to move into digital depot, but if things are changing, if it takes you like whole day to create 3D asset, they can never do that. With our solution now, they are able to capture everything that is happening. They can start working with robots and all those things much faster.
Yeah, in the video that you see, just you basically, the whole scanning kind of took around 5 to 7 minutes. You just walk around. In real time, we are kind of streaming that feed to the software, which is on the server side, which kind of stitches it all together, automatically identifies what the object of interest is, segments out all the noise, and then throws out the 3D model to you. And this, like, overall, like, took us around 20 minutes to do it. So it's obviously is a function of how big the asset is. So this took us around 20 minutes. And here, as he said, like, when you are looking at the choice of the device that you're going to use depends on what really you're looking for in the asset. For example, if you're doing a large area scanning, which is the case for a wing or the whole aircraft, that's where the HoloLens kind of shines in a big way. But when you're looking to do that, or to get the finer details in maybe an electrical panel or any componentry, that's where, like, we look for other devices like an iPhone 15 Pro, which has the RGB and the LiDAR, and then we can do that with an iPad, but that's a choice that we do on what we are looking at. And we have some video of that as well, like I'll just kind of play. Yeah, Rishi, right. You can go ahead, yeah.
So as Dijam mentioned, right, so in this case, on the left-hand side, you see a Boeing 747 panel. And there are similar use cases that we are working with customers that they don't want people to be entering into the plane to repair these things, right? So, but they don't want to bring in a lot of infrastructure to create digital assets. So in this case, we are able to create that just with an iPhone, and all of these are within a couple of millimeter accuracy. So once you enable these use cases, now digital asset creation, the cost is really like, it's almost negligible in these use cases, right? So here we use iPad or iPhone with a LiDAR, right? And this is the use case. As we said that we are using multimodal systems, so these are if your use cases are somewhere that it works well with couple of millimeter accuracy, iPad, HoloLens, those will be enough for you. But overall, we are building a software system, and future, we can definitely integrate other devices as needed.
So in this case, for example, the Boeing side panel that you saw, it took us 7 minutes to do that from scan to model. And then there is, so this again is trying to see like how well it does when you are kind of scanning the engine with like all the wires and the details that you require. This is scanning that has been done using the iPad. We basically kind of collecting the sensor data and then putting it to our server side, where then we stitch it all together. And it all happens in real time because we kind of send the sensor feeds in real time to the server side. and then we are able to kind of stitch it all together. And we are able to hit those, 1, 2 millimeter accuracies. And in this case, you can see, like, we basically place, we did that scanning, then we place the scan along with the real one. Unless, if you obviously dig deeper, you will be able to kind of find which is the real and which is the scan one. But all that we want to show is pretty close to what you are seeing in the real world.
And wherever you see differences, you can go scan more data, right? Like we show the real world that what are you scanning. So you can go and fill those in, like we provide you guidance. But a lot of time we have shown people and they are not able to figure out which is the real machine and which is just the 3D scan. So that really it captures at a very high detail just with the.
So for this case, it took us total 8 minutes to create this from scan to model. So one of the key extension of the capabilities that we have built, like fundamentally what we have done is we can look at an asset and be able to kind of reconstruct it in 3 dimension with millimeter accuracy. Also, we also have the ability that we can overlay that virtual model on the physical asset on a millimeter accuracy. What essentially it helps us do is if you have a ground truth or a reference model that you want to compare with what you are looking at right now, effectively we can do a digital diff and highlight that where all the differences are. And now you are able to utilize that capability to do some of those use cases, for example, doing anomaly detection or FOD detection. Or you are looking to kind of do like a classic problem of missing bolts that we are all aware of. And you can basically kind of eliminate some of those challenges by using the holographic inspection instead of the visual inspection that a person needs to kind of do. So I'll show you a couple of those videos around that. So this is more around the anomaly detection. It's more like you are kind of placing some additional objects or foreign objects in a place which should not be. And then we are basically kind of scanning that to highlight that from the reference model, what the model that is there, what is the difference. And so in this case, we're going to kind of put a few objects in there. So what you see here is also the red that you see is we have actually 3D printed from a CAD model, the reference model that we had. It even highlights what those differences in the 3D printing that is there. And now we are placing different, there is a battery, there is some, the circles and all that we placed. And then we just scan using our software again. Then it's able to highlight where all those additional components kind of came in, right? So that's just to kind of highlight, and that you can extend it for different use cases. And then I'll also show you the other one, which is around so the first one was around kind of putting something additional into it. The second one is more about what's missing, right? And so here you see there are the couple of bolts that's kind of, all the 8 bolts should have been there, and a couple of them are kind of missing right now. And this is the reference model that we have, and then we would then we'll scan that. Once we scan it, it's able to highlight which are the ones which are in right place, which are the ones which is missing, right? And you can keep changing, and it's a demo that's there on our booth. Like if you're interested, you can stop by and just check it out for yourself, do any variation around that, and play around with this capability. Now this unlocks many different scenarios. We're just kind of showing you a couple of them. And there's quite a bit that we are kind of working on various contracts that we have right now.
Just quickly add, like as Dijam said, right, that because you're able to now create data also so easy and faster, you can start now creating a how historically the parts are changing in this scenario, right? So, and those, as you said, that as you solve that problem, now our customers are able to think about that creating data is so cheap. So this can be extended to historical evolution of your machine's parts also.
Yeah. And some of those demos are there in our booth around how are we spatially logging this and what are the different kind of metadata that we are able to pull in. So you can check it out more in our booth. And then, yeah. So one last use case, which was something that we never really conceived of, but and that's the beauty of kind of working with the end users is, we get the understanding of their problem, we have certain technology capability, and together we were able to find something that we would have never conceived sitting at home, right? So this is the work that again we are doing with one of our customers. They are kind of using the robotic arm to do a lot of the painting, depainting, grinding, and there's a whole lot of sustainment activity that kind of go on. The challenge for the robot is to kind of, first locate the workpiece and then be able to kind of understand the 3D coordinate of the surface that it needs to kind of do the painting in this case. To make it understand, the process they earlier had was, they would put an expensive custom laser camera on top of a tripod. They take it around the whole workpiece, recreate that, the 3D coordinate of the surface that needs to be kind of painted, and then if you see at the base, there is actually a black, tape which says that you need to always get the workpiece and place it exactly at the same location. That is the only way the coordinate system of the workpiece where it's there and the robot would be able to know. But the whole process of setting this up pretty much took them like a couple of hours minimum, depending on the size of the object they're doing. This is for example, is it a dome? Then if it's the wing, then it takes longer time. So what we were able to do is, we were able to kind of shrink the time that was taking 2 hours to close to 15 minutes just by kind of bringing in a automation using the HoloLens. So what we effectively did was, instead of technician taking the tripod with the camera going around that, the technician wears the HoloLens. They just walk around this whole area for around 5 minutes. In real time, we are basically streaming all that coordinate, what you saw on the digital twin creation part of it. We get the whole coordinate system. While we get the coordinate system and the 3D of the surface of the workpiece, simultaneously we are localizing with respect to the robot where the workpiece is. You're no more kind of constrained to kind of put that workpiece at exactly the same place. It could be misplaced a little bit here and there, but it can still be kind of taken care of. And in real time, we are basically through an API transferring that coordinate system to the robot. And then the robot, kind of before it goes and does the job, there is a simulation of that path of the robot happens, and even the simulation of the outcome of that painting process. And there are many variables to that. And then once you simulate, you see it's good, it's not going to collide. You basically go ahead and do the job. So that's basically how we have been able to kind of simplify like one of the use cases. There are similar other use cases that are there for even the mobile robots. If for path planning, we can find what's the object that has come in, and we can basically in real time tell in real time we can help the robot kind of take a different path to do the job. So this was another interesting use case that was there. As I said, like some of those demos are there in our booth. If you have some time, please stop by. And now we are happy to take any questions you may have.
You can just raise your hand if you have any questions. I'll bring the mic.
You said that the iPhone, you can bring you the mic in 1 moment. Sorry, 1 moment.
Yeah, we got to use the mic for the virtual.
No problem.
Yeah, go.
Yeah, I was just curious about the model, the density of the data. Some of these scanners, it's like millions and millions of points. So when you stitch it together and remove the noise, is it really dense, a lot of polygons, or can it be more minimal?
And so So the aim is like definitely, and we create it, run all of these on the server side, and we want to capture as much detail as possible. It won't give you it is millions of points, but it is up to a millimeter, like couple of millimeter accurate, right? So the triangles will end at a millimeter accuracy, but some of the scanners that you will see, they can give you micrometer accuracy, right? But they can create 500 million polygons, but this won't do. But 90% use cases, this accuracy works, but definitely it is tens of millions, not, and you can decimate it after that if you want, but our aim is to capture as much detail as possible because customer is trying to reduce downtime, so their focus is to capture data as much as possible so they can build analytics. Like in 1 year, they have enough data to build analytics.
Thank you. So you said that with iPhone or handheld devices, you can go around and take these pictures. So a couple of questions. A, if the hand shakes or you go across the same area multiple times trying to scan this piece of equipment, how do you figure that out, or is that even an issue? Second is, what is the level of expertise required for the person doing it? Does it have to be a special technician? And I'm thinking from an oil and gas perspective, so in a refinery or a pipeline environment, do you need a specialized person to go and do the scanning, or we can ask one of the supervisors or a person over there to just do it? And the third is, can it do geotagging or spatial tagging as it is doing it? So if you have, again, a refinery or a pipeline, as the person is moving from asset to asset, scanning it, can it globally geotag that as part of scanning?
Yeah,
So the shaking of hand is not an issue because the SLAM helps remove all of those. We can synchronize those, right? And in our use cases also, basically Air Force, other customers on commercial side, frontline workers are doing it, right? So, but in the beginning, when we give you the solution, we will come and train them, and then system itself has a guidance that you are missing these places, right? And you will be able to see how the model looks like before the full processing happens. So whichever area is missing, you go again, scan more. And once the system says that I have enough data now, I will create it. So really it is meant for frontline workers, so you don't need any expert scanner to go and do that work. And geotagging is definitely possible, and we did not show that video, but our customer want to align, but we showed in the last one, if you saw, they want to put a lot of IoT data in there, right? So you can bring in all kind of IoT data to spatially align on those, and those pipeline is already there. So we have not seen in aerospace because these depots, everything is in that depot. Depot owns everything in the world for that plane, but the platform supports it, and we can easily extend it to that.
What is the scanning range of an iPhone, iPad? Is it like 5 feet, 10 feet, 25 feet?
So HoloLens is 1 to 5 meter, right? And then these again, this is one device, but Vision Pro is just another of these same hardware. So that will have that has a better. It's just that Apple is still not opening those, but you will easily see 1 to 5 meter. If you need something, we have our customers, but 90% customers really like these because you're not putting infrastructure in place, right? There are, as you were mentioning, there are other static sensor. Problem is that these environments are very harsh. So our customer will put those, they will go and paint the parts, and it will destroy the cameras, right? So if you have those use cases, we can support it because software is agnostic, but everyone wants this for now. But there are use cases where if you want to, and we have those customers who want to scan 100 meter away, right? So there we will have to integrate those cameras, but whatever we see in manufacturing processes, these are good enough.
Awesome. Thank you. Please give a hand to our speakers.
Thanks a lot.
Everyone.
Yeah.